Hello everyone and welcome back to another video. In this video we are going to understand about what branches in Git are and how do they work. So up until now we have talked about what Git exactly is and how it is different from other version control systems. We have also went through the basics of Git, the basic commands of Git and how to get started with it in the last session. But whatever we have covered up until now, we have came across a few things like how Git works and what snapshots are in Git. We have also came across things like checksumming, like Git does some checksumming that helps maintain integrity in Git. And I'm sure that a lot of you still would have a lot of doubts in what those things are, and a lot of it might still be technical jargon for you. So if you are one of them, if you have doubts against it and you want to understand branches pretty deep in Git, then this video is for you. It's a gold mine for you. So do make sure to watch this video till the very end. If this is your first video in this channel, then you can check out my other videos. This video is a part of the Git Masterclass series that I'm making, which is again a part of the web development course. So do make sure to check out those playlists. The link to them would be in the description below. And without any further ado, let's get started. Nearly every version control system that is out there, they have some sort of branching support in it. So what exactly are branches? So branching simply means that you can diverge from the main line of development and you can continue doing your work without messing up that main line of development. So you can diverge from the main line of development and continue your work without messing the main line. Now in many other version control systems, this process of branching is a very resource expensive operation to do. The reason behind it is that whenever you create branches, it requires you to make a separate copy of the directory of your project, right? And if your project is very large, it is going to take up a lot of time and space and things like that, right? Now for Git, the branching model is sort of a killer feature, right? And why it is a killer feature? So the first reason is that the way Git branches, it is pretty lightweight and all the operations that you want to do are pretty much instantaneous, right? And we'll understand why it is lightweight and instantaneous, right? So the first reason is that it's lightweight, the process is lightweight, and operations are instantaneous. Now the second reason is that switching back and forth between multiple branches is almost as instantaneous as creating branches and things like that, right? So switching back and forth is easy or fast, you can say. Right, so switching back and forth is pretty fast. Now, understanding and mastering Git branches is a very powerful and unique tool, and mastering it can sort of change the way you develop, right? So this video is very important if you are new into software development or you're not aware about branching or you really want to dive deep into how it works behind the scenes. Now if you remember from earlier, Git doesn't store data as a series of changes or differences, but it rather stores data as a series of snapshots, right? Now when you make a commit, Git stores a commit object containing the pointer to the snapshot of the content that you staged, right? So it stores a commit object. I'll just write the commit object here. Now this commit object, apart from containing the pointer to the snapshots, it also contains some other details as well. Details like name of the author, email, commit message, whatever you write in your commit message, Apart from all this metadata, it also contains a pointer to the commit or commits that came directly before it, right? Its parent commit, right? So it also stores pointer to its parent, could be multiple commit or commits, right? So this git commit object contains all of these things. Now when we initialize a repository and make our first commit, right, in that scenario, that commit is going to have zero number of parents because it's the very first commit that is there, right? So zero parents are for initial commit, right? Then one parent is for a usual commit, for normal commit, any commit that is after the initial commit. Then it can have multiple parents for a commit that results from the merging of two or more branches, right? So it can has multiple parents for commit resulting from merging two or more branches. Okay, so that's how it usually works. Now I'm sure that when I say this statement, that when you make a commit, Git stores a commit object that contains a pointer to the snapshot of the content that was staged. It's pretty difficult to understand what's going on, right? And we still, are not exactly sure what a snapshot is and things like that. We just know that it's a picture of it, but how does it work internally? So let's visualize this entire thing, right? I'll quickly scroll down, and before doing anything here, let's just do one thing. Let's create a repository, a Git repository, right? So in the last video we created a repository known as Apoorv on Git, right? I'll quickly delete that one because I don't need it, right? I deleted this. Now I'm going to again create a directory, Apoorv on Git, which is my Git username. We are going to start from scratch. I'll go into that directory. Now I'm going to create three files: readme.md, a license file, and an a.txt, a random text file. Right, I create these files, I do an ls, and I can see that I have all these files listed. Right, now let's add something in readme.md. I'll first add something. I'll not use vim. I'll first add something in my license file. So here I can add an MIT license, right? A simple text, doesn't matter, right? I can go into my readme.md. Here I can add that hi, this is Apoorv Goyal, right? The text might be small, but don't worry about it. I'm just adding some text, and I'll leave a.txt as it is, right? I'll initialize the repository, get in it, and I can see that the default branch name that it has created for me is master. So I'm currently on master branch, you can say, right? And I create this, I initialize this, get in it. Now I'm going to stage all my files. So git add dot, and now I can see that all my files are added. So it says that I'm on branch master. I have no commits yet, and I've the changes to be committed, which means that the things that are in staging area are these three files, right? And I'll simply commit it, right? So I'll do a git commit -m, and I'll write initial commit here. I press enter, and my GitHub repository has its first commit now. Now we have made the commit and we have three files inside it. Now let's try to come back into the statement that we were discussing and try to understand what does it mean. So I typed the statement here that when you make a commit, Git stores a commit object that contains a pointer to the snapshot of the content that you staged. So in our case, what did we exactly stage? We staged 3 files into Git, right? So the first file that we staged was a simple a.txt, right? So this was the first file that we staged and it had some content in it. It's a plain file, but it might have some content in it, right? The second file that we staged was a readme.md file. It again might have some content in it, right? And the third file that we staged was our license. Now this license might again have some content in it, right? So these are the files that we staged initially. So now this statement says that when you make a commit, Git stores a commit object that contains a pointer to the snapshot of the content you staged, right? So these were the files that we staged, right? Now what does Git exactly do when we stage a file, right? So when we stage a file, the first thing that Git does is that in the first video we talked about how Git uses SHA-1 hash to for everything, like to maintain its integrity, right? So it computes a checksum for all the files that we stage, right? So the first thing that it does is computes a checksum for each file. Now it stores the version of the file in a Git repository. These versions can also be known as blobs. Now the third thing that it does is it adds that checksum into the staging area. Now in the first video we also talked about how when Git checksums anything, it doesn't checksums it based on the name of the file or something like that, but it checksums based on the content of the file, right? So whenever you stage a file, let's say we stage these 3 files, it creates a hexadecimal SHA-1 hash for these files, a checksum for these files, right? Let's call those checksums for now blob1. Let's say this a.txt got converted into blob1, a checksum based on the content of the file, right? This got converted into blob2 and this got converted into blob3. So that's what happens when you stage a file, when you stage certain files into Git. Now when you create a commit, when you create a commit, Git checksums each subdirectory and stores them as a tree object in the Git repository, right? So it checksums each repository, each subdirectory, and stores it as tree object in Git repository. Right. So in the visualization, what happens is, if I had to visualize this here, so it creates a tree object. You can say that this is your tree object, your tree, and now it will, contain the contents of all the subdirectories that were there. So basically it will contain your blob that was blob1, or you could also say a.txt. Right, it will contain your blob again. In our case, I'm talking about which whose checksum was blob2, and the name was readme, and it will also contain one more. uh, what shall we do? We'll create that box later. Yeah, it will create one more blob whose checksum was blob3, right, and the name was license. So it will create this tree, right? It will checksum it, again give it a name, let's say call it tree1, right? And this tree would be pointing to all the blobs that are the version of that file, and this tree is known as a snapshot. So this is what Git stores when it creates a when you create a commit, right? This entire thing is a snapshot. So this points to all the files that you staged, right? So here we say that when you make a commit, Git stores a commit object that contains a pointer to the snapshot, right? So this is your snapshot here of the content that you staged. So this entire three files, these were the contents that we staged here, these three files, right? This was the content that we staged, and Git created a pointer to the snapshot of the content that we staged. So the snapshot is pointing towards all the blobs that are there, and there would be another commit object here. Let's call this one a commit object, right? Which is going to point towards the snapshot, right? And let's say that this commit object's checksum is known as com1, because I cannot create hexadecimal strings here. Now this will be the commit, right? So these were blobs here, right? These were your blobs here, right? Blob1, blob2, and blob3, right? This was your tree here, and this is your commit. Now this will be pointing towards a tree, right? So the tree it is pointing towards in our case currently is tree1, and it won't be, this tree1 is the checksum value. I mean, I have written it as tree1, but it is going to be an SHA1 hash based on the contents of, like, whatever it is. Then it will also contain some metadata like who is the author. Let's say that author is me, Apoorv, right? Some other details like email and message, commit message, and things like that. It should also contain a parent here, and parent would point to some other commit object that is there, the checksum of some other commit. But since it is the initial commit in our case, it wouldn't have a value for parent here, right? But this is entirely what it is, right? Now, I mean, after looking at this thing, it must be making a little bit sense of how Git works, because earlier we talked about whenever you make a change, right? Git, maps it to the snapshot of that particular blob, right? So let's say that I were to make another change here, right? Let's just come back here for a bit, right? Let's say that I made another change here. I opened up my readme.md file, right? And I added a full stop at the end. It's a very simple change, didn't do much, right? And I'll again like add that file. If I check my git status here, I will see that I just modified one file, readme.md. So I'm quickly going to add it. I'm quickly going to commit it, and I'll name it as grammar fix. So my message would be grammar fix in this, right? And yeah, I committed my changes this time, right? So now what happened, what do you think would happen in this thing? Will it again create checksums for all of these files? No, right? I mean, what would happen is that this time it would be commit 2 in the new one. This would be commit 2 pointing towards tree 2, right? So this again would be tree 2. This snapshot would become tree 2, right? And here it will again point towards blob 1, which is a.txt. It will again point towards the same blob 3, which is our license, but this time it will, instead of pointing towards blob 2, which was our readme.md, since we made some changes there and we staged that file into the next commit, it will create a new snapshot for this blob or this file, blob 4 you could say, and this snapshot this time is going to point towards blob 4. So instead of blob 2, it is going to point towards blob 4, and here again instead of blob 2 this will become blob 4, right? And this would be my commit 2. Right, so it didn't create a new copy for a.txt or license. It didn't create new snapshots for these blobs. It only created a new snapshot for the blob readme.md, because that was the only file that I changed, right? So that's why I mean Git works so instantaneously and fast, and that's how it's able to maintain all the versions, right? Now we see what blobs are, we see what snapshots are, and we also somewhat understand what commit objects are and how they are pointing towards each other, right? So I hope your understanding of snapshots and blobs is clearer than ever, right? But let's understand what happened when we what happens when we make some changes, right? So let's say again that we have a commit object, a com1, right? This is our commit object, and this commit object is going to contain all the things. So this is our commit object. Now this commit object would be pointing towards some, and this commit object would also have some size, right? So it would be pointing towards a tree. Let's say that tree is tree 1. It will be pointing towards a parent, but since this is the initial commit, then it parent would be nothing, right? It will have some name. Let's say the name is Apoorv because I made this, right? It will have an email of the author or something like that. It will have some message, the commit message, whatever the commit message was, right? So let's say that this is one commit that is there, right? Now when you make another commit after this one, I made the second commit, right? The second commit will have another checksum of it, right? Let's call that checksum com2 for now. It will again contain all the details like the previous one. It would be a commit, right, with some size. It will be pointing towards a tree. Let's say that tree is tree 2, right? It will have a parent. Now this time the parent would be com1 because it got created right after com1. It's direct previous commit, right? And again it will have some name and other details, right? Then let's say if we do another commit called com3, right? It will again have a lot of details inside of it, and its parent commit is going to be com2, right? And all of these commits are going to be linked with some snapshot, right? This would be linked with snapshot a, whose checksum was tree1, right? It is going to be linked with snapshot 2, so on and so forth. Snapshot b, whose checksum was tree 2, and this will be linked with c, right? So on and so forth, right? So that's what usually happens. So whenever you make some changes and do a commit, the commit is going to store a pointer towards the previous commit that came immediately before it, right? So for commit 2, commit 1 was its predecessor. For commit 3, commit 2 was its predecessor. So it will store a pointer to the parent commit that was there, so that it know that before this commit the previous version was this commit, right? Now that you understand the concept, let's switch to a little neater diagram, I'm just going to create a simple com1 which represents commit 1. Pointing to it would be com2 which is commit 2, and pointing to this one would be com3 which would be commit 3, right? So here we have the commit objects. Now what exactly is a branch in Git? So to answer that, a branch is simply a lightweight pointer that you can move around to any commit that you want. So currently, I mean, let's say I made 3 commits as of now, right? So currently I'm going to have a master branch. The name of my branch is master, if you remember. So I'm going to have a master branch which would be simply pointing towards commit 3. This is simply what a branch is. Now let me just quickly make one more change. I mean, I currently just have 2 commits in my branch, so I'll just add one more commit. um, I'll change my a.txt file and I'll say that this is a random text. Right, I'll save this. I'll add this. I don't have to push it anywhere. It's just a habit. Right, so now my project directory has 3 commits, right? The initial commit, the commit where I made some changes to the readme.md file, grammar mistakes and all that stuff, and now the third commit that I made. So my master branch is currently pointing towards commit 3, right? Now let's say I want to create a new branch. So to simply create a new branch, what I can do is I can do git branch, a simple command, and then the name of the branch. Let's say that I want to keep its name as testing, right? I press enter, right? And what now happened is that another pointer got created named testing. Another pointer got created called testing, which is now pointing towards this commit 3. I can check all the branches that I've created by a simple get branch command without adding anything after it. So if I do a get branch, I can see that I have 2 branches right now. I'll just increase the text size. So I have this master branch, and the star means that I'm currently in my master branch, and I have this testing branch that I just created, right? So this get branch testing, what this command does is that it creates a new branch, but it doesn't switches to the new branch automatically. So I'm still in the master branch, but it has just created a new branch for me. Now how does Git know what branch I'm on right now? So for that, Git has a very special pointer that it keeps for itself, and the name of that pointer is head. So this is the pointer, and this pointer points towards the branch that is currently active, right? So now let's say if I want to switch my branch to testing, what I can do is I can simply do a get checkout branch, get checkout, and then the name of the branch. So I want to check out the testing branch that I created, right? I press enter, it says that it switched me to branch testing, right? And if I again do a get branch now, it will tell me that again I have 2 branches, master and testing, but this time the testing has this asterisk before it, right? So this means that my testing branch is active right now. And what would happen now, I mean, if we go by this diagram, is that this head branch is removed. This head pointer is now not pointing towards the master branch, but instead this head is somewhere here pointing towards the testing branch. So this tells Git that now the active branch is not the master branch but the testing branch. So I made a new branch. Now let's say that I make some changes into this, right? Let's say that I am in testing branch right now. Let's say that I open my readme.md file, and I just add I am a software engineer. So I'm just making some changes to a file. Right, I save these changes. Right, I basically do a git add. Right, if I check the status, it will tell me that readme.md has been modified. I do a commit and I simply say occupation added. right? So now what happens is that it created another commit for me, right? In this diagram, I can say that another commit got created for me. A commit 4 got created for me, right? But and this commit is pointing towards this, right? But since I did this in my testing branch this time, what would happen is that this pointer for testing that was pointing towards commit 3 earlier is now pointing towards commit 4. So now my testing branch has moved forward towards the new commit. It's pointing towards a new commit, but my master branch is still pointing to the commit that I did before checking out to the testing branch, right? Which was my third commit, right? So now if I, let's say, check out into the master branch, I do a git checkout master, right? I mean, just to show you, I'll simply do a get it on readme.md and I can see that currently this file contains this text. Hi, this is Apoorv Goel and I am a software engineer, right? Now if I, let's say, check out my branch with a git checkout master, right, and then I again check readme.md, this time I'll see that it doesn't contains my occupation. It still is on hi, this is Apoorv Goel, right? So it's still on commit 3. It hasn't moved on commit 4, which my testing branch did because I switched to that branch and then made some changes. Here I can observe that it has reverted all the changes to the snapshot that was associated to my commit 3. Now this also means one more thing, that whatever changes we make from here on out are going to diverge the two branches. So like, just to show you one thing, what I'm going to do is I'm going to open the license file here, right, and here instead of MIT license I am simply going to ask for the GNU license. So instead of MIT I'm changing this to GNU, right? I am closing this. If I check out the changes that I made from git status, I can see that I modified my license file, right? So I'm simply going to add it and I'm simply going to commit it, modified license, right? I press enter. I have made the commit. Now what happens is uh, I'll just I'll just draw it again, rather than changing that. So what happens is that, let's say that this was my first commit, this was my second commit. The second commit was pointing towards commit 1 and I have had the C3 pointing towards my commit 2. Now from here I created a C4, my fourth commit, on which currently my testing branch is pointing towards. So my testing branch is pointing towards C4. From here I made another commit C5 to which my master branch is pointing to, right? And the head is currently on the master branch, right? Head is not at the testing branch, it is currently at the master branch, right? So this is how my diagram now looks like. And here if you see, from C3 onwards the code has diverged into two directions, right? C4 in the testing branch and C5 in the master branch. Now because a git branch is simply a file containing a 40 character SHA1 checksum of the commit that it is pointing to, for in the case of master it is a simple file containing a 40 character checksum of C5 commit 5 that it is pointing to, and for testing it is again a file containing a 40 character SHA1 checksum of our fourth commit C4, right? So since they are the simple files, they are pretty easy to create and destroy. And creating a branch is as simple as creating a file with 41 characters, your 40 character of SHA1 hash and a new line, right? Now whenever we make a commit, we also record the parent of that commit. So in a sense it's pretty easy to find a base for these different streams that went on C5 and C4. It is pretty easy to find a base for these streams whenever we want to merge these branches together. So it's generally very easy to do. If you want to create a branch and check out into it with a single command, you can simply do a git branch and then hyphen B, and then the name of the branch. Let's say testing 2. So if I press enter to it, it will create a branch called testing 2, and it will check that testing 2 branch out for me, right? So that's one way to do it. Now from Git version 2.23 onwards, so for me currently it's 2.34, so I can probably use git switch command, but from 2.23 onwards there's a command known as switch in case you want to switch branches. So I can simply do a git switch to testing, and again it switches me to the testing branch. If I want to switch back to the previous branch that I came from and I don't remember the name of the previous branch, let's say I have a lot of branches, I can simply do a git switch and a hyphen. Right. Now, if you watched my Linux Masterclass course already, then you must know like how why this works, why a hyphen works to go back into the previous branch. Right. If I do, it says that it switched me back to master. So I don't need to know the name of the previous branch I'm coming from. I can simply use a hyphen. If I want to create and switch into a new branch, I can simply do a git switch hyphen C, C for create, and then the name of the branch, testing 2. It will create a new branch for me and switch in it for me. That was pretty much it for this video. I hope your foundation for Git is pretty clear. You understand what blobs are, what snapshots are in a much more detail now. You also understand what branches are and how do they work. Branches are simply a file, right? So I hope all of that understanding and everything that we left pretty bland up until now makes sense. Git, how it works internally and things like that makes sense, right? So that was the agenda. So that's pretty much it for this video. Do make sure to learn in public, write a nice blog about it, maybe create a Twitter thread about it, tag me in it, use the hashtag learning with Apoorv, and feel free to let me know in the comments below if you still have any doubts, if you want me to cover certain things. In the next video we are going to actually work with a repository, so I'm going to create a demo repository for you guys where we are going to actually explore how branches work, how rebasing works and things like that. So that's going to be a very interesting video because you're not just going to learn Git by watching some tutorial and trying to replicate what the other person is doing, but instead you are going to actually be working with a repository, a demo repository that I'm going to create. So you're going to go hands-on with it. As I say, learn by doing. So we are going to learn by doing. We are not just going to watch any random tutorial and things like that. We are going to learn by creating branches and rebasing branches and things like that. So all of that's going to be pretty fun, so do stay tuned for that. Like this video, let me know in the comment section below what you think, if I missed out on anything, or just give me random feedback, how you liked this video, how you disliked this video, whatever it is. And do make sure to subscribe to the channel. It really helps in growing the channel. Share it with your friends, your family, whoever wants to get into tech. Doesn't matter if they have a degree or not. And yeah, learn in public, write a nice blog, maybe a Twitter thread. Use the hashtag, don't forget that hashtag learning with Apoorv. Tag me in whatever you're creating. I'm on Hashnode as well, I'm on Twitter as well, so you can tag me there, and I'll see you in the next one. Till then,